But teacher, why is it 0 over 0?
Actually, this is where you use L'Hopital's rule.
But what is El Hospital's rule?
It's L'Hopital. L'Hopital's rule is a tool used for finding limits that are often difficult to evaluate. When evaluating limits by direct substitution, there are 7 expressions known as indeterminate form that require the use of L'Hopital's rule for further investigation.
So what are the 7 indeterminate forms?
The forms are 0 over 0, infinity over infinity, 0 times infinity, 1 to the infinity, 0 to 0, infinity minus infinity, infinity to the 0 power.
Okay, but when would I apply these?
Assume 2 functions, let's say f of x and g of x, are differentiable on the open interval a to b, where g prime of x cannot equal 0 anytime on the interval except possibly at c. If as the limit of x approaches c of f of x is 0, and the limit as x approaches c of g of x is 0, then we can use L'Hopital's rule. According to L'Hopital's rule, the limit as x approaches c of f of x over g of x is equal to the limit as x approaches c of f prime of x over g prime of x.
Oh, so we're finding the derivatives of the separate functions and then evaluating for the limits?
You got it, girl! Let me show you on your homework. As you can see here, when you direct substituted -3 into the original functions, you got 0 over 0. So let's apply L'Hopital's rule. If we were to find the derivative of f of x, the top function, we would get 2x. And the derivative of g of x, the bottom function, I would get -1 minus 2 of x. And when we plug -3 back into these derivatives, I'll get 2 times -3 all over -1 minus 2 times -3, which is equal to -6 over 5, for an answer of -6/5 as the limit. A word of caution. In order to use L'Hopital's rule, the functions must meet these 3 sets of criteria. Number 1, g prime of 0 cannot equal 0. If the denominator is 0, the limit is totally undefined. Number 2, no oscillating functions. As the limit is being defined, it must meet one single y value. Finally, number 3, the limit as x approaches c of f of x over g of x cannot equal plus or minus infinity. That means the limit is undefined.
But how would I format this on my AP test?
In order to receive full points on a L'Hopital rule problem, you have to make sure that you state that limit of f of x equals 0 or one of the other indeterminate forms, and limit of g of x equals 0 or the other indeterminate forms. And then you have to state L'Hopital's rule and find the derivatives.
Thank you, teacher. I feel ready to ace my exam.
All right, now that she's gone, I'm going to show you guys an example of L'Hopital's rule of infinity over infinity. So as you can see, this example is limit as x approaches infinity of 5x minus x squared all over 3x squared plus 2x minus 4. So our first step is going to be to plug this limit into our function. So we're going to have limit as x approaches infinity of 5 times infinity minus infinity squared for infinity, and limit as x approaches infinity of 3 times infinity squared plus 2 times infinity minus 4 for infinity. And since the limit is infinity over infinity, L'Hopital's rule can be applied, but you have to state it. All right, next up is going to be finding the derivative of our original function. So now we're going to have limit as x approaches infinity of -2x all over 6x. So when we plug our bounds into this new function, we're going to get limit as x approaches infinity of -2 times infinity for negative infinity, and limit as x approaches infinity of 6 times infinity for infinity. And again, negative infinity over infinity is an indeterminate form that requires the use of L'Hopital's rule, so we're going to use it once again. All right, finally, now we're going to find the derivative of our new function, so we're going to have limit as x approaches infinity of -2 over 6 as -1/3 for the limit. However, there is a little trick. In our original function, since -x squared and 3x squared are to the same power, we can actually take the coefficients of these numbers, which is -1 for the negative x squared and 3 for the 3x squared and find our derivative that way. Finally, I'm going to show you guys an example of a problem that requires numerous rounds of L'Hopital's rule and the unit circle. So first up, let's plug in our bounds to our equation. So we have limit as x approaches 0 of 0 cubed for 0, and limit as x approaches 0 of sine of 0 minus 0. And thanks to my handy dandy unit circle over here, we know that sine of 0 is 0, so 0 minus 0 is 0. So 0 over 0 warrants L'Hopital's rule. All right, second round. Now we're going to have limit as x approaches 0 of 3x squared all over, remember the derivative of sine x is cosine x minus 1. And if we plug 0 back in, we're going to get 0 on the top. And cosine of 1 over here again is 1. So 1 minus 1, 0 over 0. So L'Hopital's rule once again. All right, this time, limit as x approaches 0 of 6x all over negative sine x. So now we're going to have 6 times 0 all over negative sine of 0, which is 0 over 0. For our last round of L'Hopital's rule, we are going to end up with limit as x approaches 0 of 6 all over negative cosine 0 for 6 over 1, negative 1, with a limit of negative 6. Remember, guys, there's no limit to the number of L'Hopital rule rounds that you need to do.